Hello friends, welcome to the video lecture series on digital image processing. I am Dr. Dafda, and in this 47th video class of DIP, we will study JPEG 2000, which is a wavelet based compression. It is called JPEG 2000 since it was created by Joint Photographic Experts Group in the year 2000. The JPEG standard, which we learnt in the previous video class, has the disadvantage of blocking artifacts due to spatially disjoint pixel blocks. How to remove this disadvantage? This disadvantage is removed by JPEG 2000. So let us start. Now, why JPEG 2000 was formed? It was formed since JPEG standard has got certain limitations. First is low bitrate compression. JPEG offers an excellent quality at high and mid bit rates. However, the quality is unacceptable at low bit rates, below 0.255 bits per pixel. Next is lossy and lossless compression. JPEG cannot provide a superior performance at lossless and lossy compression in a single code stream. Next one is transmission in noisy environments. The current JPEG standard provides some resynchronization markers, but the quality still degrades when the bit errors are encountered. And last one, different types of still images. JPEG was optimized for natural images. Its performance on computer generated images and bi-level or text images is poor. So to overcome these limitations, JPEG 2000 was formed. JPEG 2000 is based on discrete wavelet transform. This DWT decomposes the image using functions called wavelets. What is a wavelet? A wavelet is a small wave. The main advantage of wavelet transform is that it offers a simultaneous localization in time and frequency domain. That means it has ability to extract both spatial and spectral information. The idea here is to have more localized analysis of the information, which is not possible using DCT functions, whose spatial supports are identical to the data. JPEG 2000 distinguishes itself from JPEG compression standard not only by its virtue of higher compression ratio, but also by its many new functionalities. The most noticeable among them is its scalability. From a compressed JPEG 2000 bit stream, it is possible to extract a subset of the bit stream that decodes an image of variable quality and resolution. This shows the difference between operation of JPEG and JPEG 2000. For JPEG, the first module, pump and part, performs component and tile separation or partitioning. Component separation means separation of image into color components Y, CR and CB, and tile separation means separation of image into different non-overlapping blocks. Next is DCT, quantization and run length coding to obtain final bit stream, as we understood in the previous video class. For JPEG 2000 also, initially there is component and tile separation. After this pre-processing, we now apply a wavelet transform which yields a sequence of wavelet coefficients. This is the key difference between JPEG and JPEG 2000. We next quantize the wavelet coefficients, which are then regrouped to facilitate localized spatial and resolution access, whereby resolution we mean effectively the degree of wavelet coefficient, as the wavelet decomposition is thought of as the expansion of original data vector in terms of basis, which accounts for finer and finer detail or increasing resolution. The degree of resolution are organized into subbands, which are divided into non-overlapping rectangular blocks like this. Three spatially co-located rectangles, one from each subband at a given resolution level, form a packet partition. Each packet partition is further divided into code blocks, each of which is compressed by a subbit plane coder into an embedded bit stream with a rate distortion curve that records the distortion and rate at the end of each subbit plane coding. The embedded bit stream of a code blocks are assembled into packets, each of which represent an increment in quality corresponding to one level of resolution at one spatial location. Collecting packets from all packet partitions of all resolution levels of all tiles and all components, we form a layer that gives one increment in quality of entire image at full resolution. So in a nutshell, the main differences are JPEG uses DCT, whereas JPEG 2000 uses wavelet transform or DWT. JPEG partitions the image into 8x8 equal blocks and then applies transform, while JPEG 2000 performs the partition operation in the wavelet domain. And finally, entropy coding module for JPEG is run length coding, while for JPEG 2000 is bit plane coding. I hope it is clear. Let's go ahead and understand what is wavelet transform. Wavelets are functions that are defined in time as well as frequency around a certain point. So it has got both time information and frequency information, in contrast to DFT, which has only the frequency information. Wavelet is a localized image transform, and because of localized process, low frequency and high frequency components are get scanned row wise as well as column wise. Wavelets based transforms are mathematical tools which are used to extract information from images. A significant benefit it has over Fourier transform is temporal or time resolution, which signifies that it can capture both frequency and location information of images. Wavelet transform can be viewed as a projection of a signal into a set of basis functions called wavelets. Such basis functions offer localization in the frequency domain. The wavelet transform is designed in such a way that we get good frequency resolution for low frequency components, which is average intensity values of the image, and high temporal resolution for high frequency components, which are edges of the images. Now let us understand the steps of wavelet transform. Step 1, start with a mother wavelet such as haar wavelet, Maulik wavelet, Dafda's wavelet, etc. So these are different types of wavelet transforms. The image is then translated into shifted and scaled version of this mother wavelet. First, original image has to be passed through high pass filter and low pass filter by applying filter on each row. So if this is our original image, we apply low pass filter and high pass filter on each row of the original image to obtain the horizontal approximation and the horizontal detail. We know that when we apply the low pass filter, we get the approximation, and when we apply high pass filter, we get the details or the edges, right? So here we'll obtain the horizontal approximation or average value of light intensities, and here we'll be obtaining the edges of the horizontal values. Step 2, now to the horizontal approximation, we again apply low pass filter and high pass filter to the columns. Hence we get the approximated image LL and vertical detail of the horizontal approximation LH. So again, now to this horizontal approximation, we apply low pass filter and high pass filter on each columns. So this is a low pass filter, and this again is a low pass filter. So we will obtain a LL or the approximate image, which will contain the average intensity values of the image. And here this is H or high pass filter on the columns. We will obtain the vertical details LH. So we get the approximate image LL and the vertical detail of the horizontal approximation LH. Next we apply low pass filter and high pass filter to the horizontal details, and hence we get the horizontal detail of the image HL and the diagonal detail of the image HH. So to this horizontal detail, we again apply low pass filter on the columns and high pass filters on the columns. We obtain HL and HH, which is the diagonal details of our image. So now if the three detail subsignals, that is LH, HL and HH, are small, they can be assumed to be 0 without any significant change in the image. So most of the information will be present in LL, as we know that most of the image information is present in the low frequencies. So if LH, HL and HH are small, they can be assumed to be 0, or they can be neglected without affecting the quality of the image, and hence large compression can be achieved using wavelet transform. So if this is our original image, initially we subdivide this image into L and H, and further we subdivide to obtain LL, HL, LH and HH. So it is like this. This is the image which gets subdivided into 4 images like this. Again we apply the same process to obtain such images, and hence we can obtain multi-resolution analysis using wavelet transform. So this will be the low frequency information of the image, and this will be the high frequency information or horizontal details, high frequency information vertical details, and high frequency information diagonal details. So by neglecting these values or by coding these values with much lower bits, we can achieve a very large compression ratio, and still the quality of our image will be very good. So JPEG 2000 uses this wavelet transform, and these are the features of JPEG 2000. Lossless and lossy compression. So the standard provides lossy compression with a superior performance at low bit rates. It also provides lossless compression with progressive decoding. Applications such as digital libraries or databases and medical imagery can benefit from this feature. Protective image security. The open architecture of JPEG 2000 standard makes easy the use of protective techniques of digital images such as watermarking, labeling, stamping and encryption. Region of interest coding. In this mode, regions of interest ROIs can be defined, and these ROIs can be encoded and transmitted with better quality than the rest of the image. Robustness to bit errors. The standard incorporate a set of error resilient tools to make the bitstream more robust to transmission errors. This slide shows the block diagram of JPEG 2000, which is already explained. Now let us compare JPEG and JPEG 2000, which is a very important question that is asked in the exam. JPEG was created in 1986, JPEG 2000 in the year 2000, and it is comparatively a new standard. JPEG uses only lossy compression, whereas JPEG 2000 offers both lossless and lossy compression. JPEG codec has low complexity, whereas JPEG 2000 codec is highly complex. JPEG gives single resolution and single quality, whereas JPEG 2000 gives multiple resolution and full quality scalability. The compression ratio obtained by JPEG is around 10 to 20, whereas the compression ratio that is achieved using JPEG 2000 can be around 30 to 200, which is very large. JPEG uses discrete cosine transform. JPEG 2000 uses discrete wavelet transform. JPEG uses less computational complexity and computation time is also less, whereas JPEG 2000 requires more computational complexity and computation time is also more. Blocking artifacts are present in the image and regions of interest can also not be selected in JPEG, whereas the blocking artifacts are not present in the image for JPEG 2000 and image quality is very good and regions of interest can also be selected for quality. JPEG is used widely on the internet and in digital cameras, whereas JPEG 2000 is widely used in medical and wireless multimedia arenas. The file extension for JPEG is JPEG or JPG, whereas the file extension for JPEG 2000 is J2K, JP2 or JPX. So if we compare the images obtained using JPEG and JPEG 2000, so you can see the quality of JPEG 2000 is very high as compared to JPEG. If this is the original image, JPEG 2000 gives a very high quality compression in spite of low image size as compared to JPEG. Let us implement JPEG 2000 in MATLAB. This is the MATLAB code for JPEG 2000 compression. We are reading an image, Peppers.png. And using inbuilt MATLAB function for two-dimensional discrete wavelet transform, we are applying haar wavelet to our RGB image and subdividing it into LL, LH, HL and HH and subplotting. And we are writing the Peppers image in the output folder in both JPEG format and JPEG 2000 format. And I am displaying my original image, the JPEG image and JPEG 2000 image side by side for comparison, and using inverse JPEG 2000 IDWT2 I can reconstruct back my original image. Let us run and see the output. So this is the LL band of my Peppers image, this is the LH band, HL band and HH band of the image, and we can see that most of the values of LH, HL and HH can be neglected to achieve high compression. This figure shows my original image, JPEG compressed image and JPEG 2000 compressed image, and like the previous video class, let us compare by zooming this particular spice and the same in JPEG 2000. So in JPEG image we can see the blocking artifacts, we can see individual blocks if we look closely, whereas here the blocking artifacts are not present. So let us see the output folder where I have written, and let us see the size of the image. So JPEG 2000 file size is 5.5 KB, whereas JPEG compressed image file size is 22.9 kilobyte. So my original Peppers image is 280 KB. So the compression that is achieved using JPEG compression is 12.22, whereas the compression that is achieved for JPEG 2000 file is 50.90. That is approximately 51 times compression, which is very huge compression, and still the image quality is very good. And also using inverse wavelet transform, I can recover my original image back in the same quality. So we can see that discrete wavelet transform offers high compression ratio, good quality as well as reversibility, or you can say even the lossless compression. So that is all for this video class. I hope you would have gained a good knowledge from this video lecture. Thank you very much.